We have spent the last few weeks traveling to the strangest corners of the galaxy. We have seen water worlds, ice shells, eyeball planets, and methane moons. Every single one of them has a real chance to host alien life. But they cannot all be the best. On Earth, science budgets are finite. You do not get to explore everything. You get to pick one target, maybe two, and you bet an entire decade on those worlds being interesting enough to justify the price tag. So here is the question. If humanity could send a single flagship mission to only one of these worlds to hunt for life, which one actually deserves it? Today I am ranking our top 6 candidates from long shot to almost unfairly good. And I will warn you now, the most famous water world does not take the top spot. Quick ground rules. I am not ranking these by which world is the coolest. I am ranking them by 3 things. First, how likely is it that life could exist there at all? Second, how easy is it to actually detect life with the technology we have? And third, how realistic is it that we could send a mission there in the next few decades? With that in mind, let us start at the bottom. In 6th place, our cosmic next-door neighbor Proxima b. On paper, this is everything you would want. It is roughly Earth-sized. It sits in the habitable zone of its star. And at just over 4 light-years away, it is the closest potentially habitable exoplanet we will ever know about. If you are designing a sci-fi starship destination, you start here. The problem is the star it orbits. Proxima Centauri is a tiny red dwarf that behaves less like a gentle sun and more like a cosmic strobe light. It blasts the planet with powerful flares and X-rays over and over again. Any atmosphere Proxima b started with has been under attack for billions of years. Could there still be life there, buried deep underground or huddled under a thick atmosphere? Maybe. But from our perspective, it is almost impossible to check. We can barely separate the planet's light from its star, and we do not have any starships. So Proxima b scores high on drama, but low on practicality. Number 5 is a quieter, more disciplined candidate, LHS 1140b, the so-called eyeball planet. This world orbits a small red star about 40 light-years away. It is larger than Earth, likely a super-Earth, dense and heavy, with gravity to hang on to a serious atmosphere. And thanks to very precise measurements, we are pretty sure that atmosphere actually exists. That alone already puts it ahead of Proxima b, because it is probably tidally locked, one side in permanent day, one side in permanent night. The most likely configuration is a vast circular ocean on the day side, surrounded by a frozen ring of ice. From space, it would look like a gigantic blue pupil staring at its star. In the habitable zone, yes, with liquid water, very likely. But there are 2 big catches. First, if the greenhouse effect is a bit too weak, the whole world freezes into one giant snowball and that ocean disappears. Second, it is 40 light-years away. We can study its air with telescopes, but we are not landing there anytime soon. So LHS 1140b is a strong B-tier world, promising, stable, scientifically rich, but distant. At number 4, a choice that is going to annoy some people, Jupiter's icy moon Europa. For decades, Europa has been the poster child for alien oceans. Under its cracked ice shell lies more than twice as much water as all of Earth's oceans combined. The seafloor is probably hot, flexed and squeezed by Jupiter's gravity. That means hydrothermal vents. And on Earth, hydrothermal vents are some of the most life-rich environments we know. So why is Europa not higher? Because the how matters. Europa's surface is constantly bombarded by Jupiter's radiation belts, making it one of the harshest environments in the solar system for electronics and for humans. And that beautiful global ocean is probably buried under 10 to 15 miles of ice. To actually sample the water where life might be, You have to survive the radiation long enough to land, then drill or melt your way through a mountain's worth of ice, then deploy a submersible that can talk back to the surface. It is not impossible, but it is an engineering nightmare. Enormous potential, but with a brutal difficulty setting. Europa remains a legend, but not, in my view, the smartest first move. Number 3 is the wild card. Saturn's largest moon, Titan. It is the only moon in the solar system with a thick atmosphere. It has clouds, weather, rivers and lakes, but the lakes are not filled with water, they are filled with liquid methane and ethane. The rocks on the ground are solid water ice, hard as stone. From a chemistry standpoint, Titan is outrageous. Its atmosphere is full of nitrogen and methane. Sunlight and charged particles stitch them into complex organics that drift down like orange snow. It is a global factory for the building blocks of life, just in the wrong solvent. Is life there likely? For life as we know it, no, it is far too cold. But for life as we do not know it, using methane instead of water, Titan is the only natural experiment our solar system is running. And unlike distant exoplanets, Titan is accessible. We've already landed there once. In the 2030s, NASA's Dragonfly mission will send a nuclear-powered drone to fly from dune to dune, literally sniffing and sampling for complex chemistry. High uncertainty, but uniquely testable. Titan is a gamble, but if it pays off, it would rewrite what the word habitable even means. The runner-up, in second place, is not one world at all. It is an entire class. The so-called Hycean worlds. These are planets a bit bigger than Earth, wrapped in thick, hydrogen-rich atmospheres above deep global oceans. In the right orbits, that hydrogen blanket keeps them warm and stable over an enormous range of distances. That makes them statistically incredible. While Earth-like planets might be rare, Hycean candidates seem to be everywhere. Why does that matter? Because if life can exist in these conditions, under high pressure, in deep oceans beneath hazy skies, then the universe suddenly becomes crowded. You do not just get 1 or 2 habitable worlds per system. You might get dozens across the galaxy. The catch? We do not have one in our solar system. We cannot visit them. We can only look at their spectra. They are statistically perfect, but physically out of reach. Which brings us to number 1, the single best place to look for life with the tools we already have. Saturn's tiny moon, Enceladus. On the outside, Enceladus looks like an unremarkable ice ball just a few hundred miles across. But at its south pole, something extraordinary is happening. Long cracks, called tiger stripes, vent towering plumes of water vapor and ice grains straight into space. And those plumes come from a global subsurface ocean. Here is the key difference from Europa. Enceladus is doing the hard part for us. Europa hides its ocean behind miles of ice. Enceladus sprays its ocean into space. To search for life there, we do not need drills and submarines. We just need to fly a probe through the mist and taste the water. We have already found water, organic molecules, and heat. It is a hydrothermal vent system waiting for a visitor. If I had the power to sign off on one flagship mission to answer, "Are we alone?" Enceladus is the world I would bet the decade on. In fact, the mission plan for Enceladus is so solid, I made an entire documentary breaking down exactly how it would hunt for life in those plumes. If you want to see the future of space exploration, that video is linked in the comments. The real mystery is not whether the universe can host life. It is why, knowing all this, we still have not launched the mission. We do not need warp drives. We do not need miracles. The most realistic shot at finding life in our lifetime is already mapped. already measured and already throwing samples at any spacecraft brave enough to fly through its ghostly rings. But finding life is only the happy version of the story. Sometimes you find worlds that look alive, but are actually traps. Next time, we stop looking for hope and start looking for the graveyard.